Hi and a very good day. So in this video session, I will continue discuss about univariate modeling techniques. Alright. Okay. So as I mentioned before, we actually have three general classification of univariate models, where we have naive models, method of averages, and exponential smoothing technique. Right. So for the purpose of demonstration, I will provide you with the data set and you can try it by using Excel. Right. Okay, for the first part of demonstration, I will show to you on how can you project forecast value based on naive models. Okay, so let's take a look at the first members. Okay, the first member, call it as naive forecast. Okay, and this model is actually strongly believe what happened yesterday will happen again tomorrow. Okay, as example, uh, suppose that you want to forecast monthly car manufacturing, okay, for the next month, as example. So you believe that what uh, what happened this month will happen again. Okay, next, what happened this month will happen again next month. So when we want to forecast the volume of cars that can be manufactured, so you say that it is the same as this month. Okay, so that's naive forecast. As we can see here, okay, I hope that you can see clearly. Okay, so every model have their own mathematical equation. So for naive forecast, okay, what happened again? What happened yesterday will happen again tomorrow. So the mathematical equation is, okay, suppose that I choose one period, means I want to forecast the next month, the next day, okay, the next year. So ft plus 1 is equals to yt. Okay, right. So there are discussion on where this model is suitable to use. Okay, this model works best when the actual historical data series contain no discernible pattern. Means that if you say that, okay, and it perform well in series which exhibit a slow change in the fluctuation, means that there is no significant changes in your time series. So it can be, you can use naive models to forecast the value. But again, if there is actually sudden change in our current data series, okay, it will greatly affect, okay, our forecast accuracy. Okay, right. So let's take a look on this Excel example. Okay, I hope you can see it. Okay, naive. Okay, so what happened today will happen again tomorrow. So what is this meaning? Suppose that I want to forecast one step ahead. Okay, so we cannot start here because the first observation is 9060, so we don't have 9069. Okay, so we just have we have to start at this t is equals to 2 if you want to perform naive model. So what happened yesterday will happen again tomorrow, so the value is the same as the last t or the last year. Okay, 31.3. Okay, same goes to 1962. Okay, the value is the same as 1961. Okay, so you can copy. Okay, you can copy and then you paste. Alright. Okay. Oh, sorry, you have to copy at the same period of time. Okay, copy and then paste. Right. So since that we only have observation up until 1997. Okay, and this demonstration we want to forecast one step ahead. Okay, 1998. Okay, so what happened yesterday will happen again tomorrow, so the value is the same as 1997. Okay, so that's naive models. Okay, suppose that you have seasonal pattern, and what we want to focus is a quarterly data set like this example. Suppose that you want to focus at year 6 here. Okay, so for quarter 1 the value is the same as the last year quarter 1. 10.9. For quarter 2 it is the same as the last year quarter 2, 13. That example, that's naive models. Okay, and we have another members in this group where we call it as naive with trend models. Okay, the difference is instead of we use only last year observation, we want to include, or we want to take account growth component in our forecast value. So the growth component is this particular part, YT over YT minus 1. So we want to take a look on the rate. Okay, suppose that the last observation value is greater than this current value, so the growth rate is, the value is less than 1. Okay, and if the last year is smaller than this current observation, the value is greater than 1. So this particular naive trend, so it will cater the trend component. That's good. So hence, if YT is greater than YT minus 1, again, okay, you see that it is conversely upward, unless it is downward. Okay, so let's take a look at exact examples. Okay, the second member of naive models is naive models with trend. Okay, right. So the difference between naive models, trend and with trend and without. Okay, the first and the second is naive with trend is highly sensitive to the changes in the actual value. So sudden drop or sudden increase will affect our forecast value. And again, since that we will focus, as example, we want to focus one step ahead. Okay, you will lose lose some observation, the early observation here. Okay, so as example here, for naive model you will lose one observation, but for naive model you will lose two observation. Because of what? Okay, for the mathematical presentation here, okay, as example, if you want to focus 1961 as example, 1961, you need 9060 and 9059. So we don't have this 9059, so we have to start here. Want to focus 9062 is equals to 9061, the observation at 9061 times 9061 over 9060. Okay, then you write. Okay, right. So this is the value that you fitted by using naive model with trend. Okay. So and now you will have to determine, so which models actually best to generate forecast value. Normally before we generate this forecast value, we have to determine first, which model is actually best. So how do we determine which model is best? We have to use the error measure that we discussed in our last class. Error measure. So what we need, error measure. Error measure is we use this formula. to calculate the MSE, okay, you need E square here, okay, where this ET is equals to YT minus Y hat T. Means that, okay, YT minus Y hat T ni, okay, error. Okay, error. I insert, okay, because of what? I want to, we need two error, one for naive model and one for naive model with trend. Okay, so we need two error. Okay, so error for naive models, okay, actual minus fitted. This is actual value minus fitted value. Okay, and then you just write, okay, up until via, okay, the last observation, 1997 is your last observation. This color. Okay, and then for naive model with trend, okay, equals to actual minus fitted. Okay, alright. Right, and then you need error square. Error square. Just, okay, square up until here. Okay, same. Okay, right, error square up until here. Okay, so now you are ready to calculate MSE. Okay, you are ready to calculate MSE. Okay, so MSE is, okay, equals to summation of your error square here over, or we say that average of your error square. Okay, but for the purpose of demonstration, okay, normal practice in forecasting, we generally divide our data set into two parts. Okay, we have estimation part and we have evaluation part. Okay, so because of what we don't we want to divide the data set so that we can measure, okay, within sample error and out of sample error. Okay, and for this example, suppose that I use the first 30 observation as the estimation part. Okay, is color. Okay, and the last 8 observation, okay, as the estimation part. Okay, so how many n? I mean how many observation? How many observation for okay, this is not mean square error. Sum square error. Sum square error. Okay, so this is MSE. Okay, so let's calculate the sum SE. Okay, so for estimation part, okay, for the estimation part, the sum is from here to this part only. Okay, sum. Okay, sum. Right, and for evaluation part, the sum is, okay, the sum is from here to here. Okay, alright. Okay, so this is for naive model. Okay, naive model. Alright, so okay, so how many n observation you need? Okay, since that out of 30 observation we lose 1, so and here for estimation part is 29 and evaluation part is 8. Okay, 8. So MSE for okay, for this particular part is we just divide. Okay, so you will have one for estimation part and one for evaluation part. Right, so this is example for naive models. Okay, you can try sorry, sum E3. Oh, it's actually careful it is actually for this careful with your calculation. 79 SE, sum of SE. Okay, so this is correct. G alright, so this is your MSE. Okay, now your exercise is try to get this MSE for naive model with trend. Okay, and then try to compare. Okay, try to compare which smaller. Okay, for naive with trend. Okay, this is your exercise. Try to compare. Okay, which which SE is smaller, especially in evaluation part. Alright, so which model smaller, you will choose that as your best model. Okay, so that's the first demonstration. Okay, so I hope you get it. Okay, I will continue the next model in another video. Okay, thank you for listening. Bye.